Hello, today we're looking at some very important chemistry multiple choice questions, and I'll be giving you 5 seconds to answer eight questions. If the 5 seconds will not be enough, you can pause the video, read through the question, and answer the question. The first one, number one, which of the following is a physical change? A. The bubbling of chlorine in water. B. The passing of steam over heated iron. C. The burning of substances in air. D. The dissolution of sodium chloride in water. D. The dissolution of sodium chloride in water. The answer is the dissolution of sodium chloride in water. The dissolution of sodium chloride in water is a physical change because no new substance is formed, and this process is reversible. So sodium chloride is dissolved in water, but it retains its chemical identity. Now, the bubbling of chlorine in water is a chemical change because chlorine reacts with water to form hydrochloric acid or hypochlorous acid, producing new substance. The passing of steam overheated is a chemical change because steam reacts with iron to form iron oxide, hydrogen gas, leading to permanent transformation. The burning of substances in air is a chemical change because combustion results in new substances like carbon dioxide or carbon dioxide, water vapor arches, making it irreversible. But the dissolution of sodium chloride, which is same as salt in water, is a physical change because the salt can be recovered by evaporation and no new substance is formed. Number two, bronze is A or an A metal, B compound, C mixture, D element. The answer is mixture. Bronze is a mixture of copper and tin, and sometimes other elements. It is not a compound because the elements are not chemically bound in fixed proportion. Now, we have other mixtures in chemistry. We have the brass, which is a mixture of copper and zinc. We have the steel, which is a mixture of iron and copper. And sometimes other elements. We have the air, which is a mixture of gases like nitrogen, oxygen, and carbon dioxide. We have the salt water, which is a mixture of salt and water. We have the milk, which is a mixture of water, fats, protein, and other nutrients. And here are some memory tips that can help you remember the constituent of different mixture. Like for bronze, you can use this tip bronze, copper, and tin. To remember that bronze is made up of copper and tin. Now, you can use this memory tip for stainless steel. I can clean nicely. I can clean nicely to help you remember that stainless steel is made up of iron, carbon, chromium, and nickel. You can also use this memory tip, strong iron car, to help you remember that steel is made up of iron and carbon, strong iron car. You can use this mnemonic, soft lead tin, to remember that solder is made up of lead and tin. So you can write down this mnemonic somewhere so that you can visit it before your exams. Because with this mnemonic, any question asked about mixture, you can easily pass it and get 3 points from that question. Number three, a mixture of oil and water can be easily separated by A. Paper chromatography, B. Evaporation to dryness, C. Using a separating funnel, D. Fractional distillation. The answer is using a separating funnel. Now, oil and water do not mix because oil is less dense and does not dissolve in water. So when poured into a separating funnel, the two liquid forms separate layers. The dense is water and it stays at the bottom, while the less dense is oil and it stays at the top. So by opening the tap of the bottom, the water can be drained first, leaving the oil behind. So with this, you can separate using separating funnel. You can separate two two substance that do not mix. Now for others, paper chromatography is used to separate different colored dye in ink or pigments in plants. Evaporation to dryness is used to separate salt from salt water from evaporating the water and leaving the salt behind. Fractional distillation is used to separate different compounds of crude oil or alcohol from water based on the boiling point. Number 4. To separate a mixture of benzene, ethanol, and water, use A. Filtration, B. Decantation, C. Simple distillation, D. Fractional distillation. The answer is fractional distillation. Now, to separate a mixture of benzene, which is about 80 degrees Celsius, ethanol, which is about 73 degrees Celsius, and water, which is about 100 degrees Celsius, fractional distillation is required because the boiling point are relatively close. So, fractional distillation is used to separate substance that has close boiling point. You can use the word fraction to remember that when you divide something into two, it becomes smaller. So, fractional distillation is used to separate substance that have a very small or a very close boiling point. So, in using fractional distillation to separate benzene, ethanol, and water, the one that has the most closest boiling point will be the one that will to distill first. The so ethanol distill up first as the first fraction because of the boiling point is 78.3 degrees Celsius. The second fraction will be benzene because the boiling point is 80, while the final residual will be water, which will remain. Now for filtration is used to separate solid from liquid and not used to separate liquid mixture. That's why it's filtration for the answer. For decantation is used for separating immiscible liquid or solid from liquid. It is used to separate immiscible liquid or solids from liquid. While simple distillation is used to separate mixture with large difference in boiling point. But ethanol and water has close boiling point, so fractional distillation is used. So now you can use the word L in simple to remember that it is used to separate mixture of large boiling point. And you can use the word fraction now, which is dividing something into small. So remember that fractional distillation is used to separate mixture of small boiling point or close boiling point. Number 5. Hydrogen forms two oxides. In the first oxide, 2 grams of hydrogen combine with 16 grams of oxygen. In the second oxide, 2 grams of hydrogen combine with 32 grams of oxygen. What law is illustrated? A. The law of constant proportion. B. The law of conservation of matter. C. The law of multiple proportion. D. The law of reciprocal. The answer is the law of multiple proportion. The law of multiple proportion states that when two elements combine to form more than one compound, the ratio of the masses of one element that combine with a fixed mass of the other element is a simple whole number. So the law of multiple proportion states that when two elements combine to form more than one compound, the ratio of the masses of one element that combines with the fixed mass of the other element is a simple whole number. Now for here, the first oxide, which is 2 grams of hydrogen combined with 16 grams of oxygen, and in the second oxide, 2 grams of hydrogen combines with 32 grams of oxygen. Now the ratio of oxygen in the two oxide is 16 is to 32, which is to 2 is to 1. So which is a simple whole number ratio illustrating the law of multiple proportion. So for the law of constant proportion, this law states that a given compound always contains the same element in a fixed ratio. For the law of constant proportion, this law states that a given compound always contains the same elements in a fixed mass ratio, regardless of the source or the method of preparation. Example, when we talk about water, water will always contain 2 grams of hydrogen and 16 grams of oxygen. No matter how you want to prepare this water, no matter the source, no matter the method of preparation, water must always contain 2 grams of hydrogen and 16 grams of oxygen, and this is the law of constant proportion. Now for the law of conservation of mass, the law of conservation of mass states that matter cannot be created or destroyed in chemical reaction. The total mass of the reactants equals the total mass of the product. Example, in combustion of methane, we can see that carbon dioxide and water is formed. So although in looking at this equation, you think, oh, that something was destroyed or something was formed, but what just happened here was that the atoms were rearranged. They were not lost. In a chemical reaction, atoms from reactants rearranged to form product, but no atom disappear or appear out of nowhere. So there's no new element in that reaction. There's no new atom in that reaction. There's no loss of atom. There is just rearrangement of atoms. Now there is number 2, that the mass remains the same. Since the number and type of elements stay the same, the total mass remains unchanged before and after the reaction, because there's no addition or there is no subtraction. And finally, whether it's combustion, whether it's decomposition, whether it's synthesis reactions, the mass remains conserved. So this law states that the matter cannot be created or destroyed in chemical reaction, no matter the reaction given. If, for instance, in your exam, they decide to give you that of decomposition or synthesis reaction, just know that the law of conservation is still at play in that reaction. Now for law of reciprocal proportion, this law states that if 2 elements separately combine with a fixed mass of a third element, the combining ratio will be the same or a multiple of the ratio in which they combine with each other. So the combining ratio will be the same or a multiple of the ratio in which they combine with each other. So for this, let's consider sulfur, oxygen, and hydrogen. Now hydrogen and oxygen combines to form water. Sulfur and oxygen can combine to form sulfur 4 oxide or sulfur 6 oxide. Now for hydrogen and sulfur can combine to form hydrogen sulfide. Now let's examine the mass ratio. In water, the ratio of hydrogen to oxygen is 2:1. 2 is to In water, the ratio of hydrogen to oxygen is 2:16. Now for sulfur 4 oxide, the ratio of sulfur to oxygen is 32:32. For hydrogen sulfide, the ratio of hydrogen to sulfur is 2:32, which is something as 1:16. The ratio of sulfur to oxygen is 1:1, and it is a simple multiple of the ratio of hydrogen sulfide, which is 1:16, which is also a simple multiple of the ratio of water, which is 2:16, something as 1:8. So for law of conservation, for law of reciprocal, if 2 elements separately combine with a fixed mass of the third element, the combining ratio will be the same or a simple multiple of the ratio in which they combine with each other. So if these multiple choice questions have helped you or will help you in answering some questions chemistry, I want you to like this video, subscribe. Thank you for watching. So if these multiple choice questions have helped you or will help you in answering some questions chemistry, I want you to like this video, subscribe. Thank you for watching. So if these multiple choice questions have helped you or will help you in answering some questions, chemistry, I want you to like this video, subscribe. Thank you for watching. So if these multiple choice questions have helped you or will help you in answering some questions, chemistry, I want you to like this video, subscribe. Thank you for watching.